Alright, so the purpose of this video is I'm going to go over everything you need to know for the honors acid-base exam. So what I'm going to do is I'm going to pretty much do all the setups. You guys should have been able to check your answers in class, or the teachers posted the answers, or probably went over them in class, check with your friends. But once you have the setups, it's just a matter of you plugging in the calculator anyway. There's four major things that are going to be on the test. The first thing is, remember pH land, the teachers taught you this. This is the mathematical relationship pH has between OH and all the other, so like if you have H3O plus to start out with, how do you go from H3O plus to pH? You just take the negative log of it. You just punch negative log in your calculator and the value, you get pH. To go back the other way, it's 10 to the negative pH. So that's the idea. These arrows represent, it's basically like when you play the game Candyland, you're just hopping around. pH plus POH is equal to 14. H3O plus times OH minus is equal to 1.0 times 10 to the negative 14th. So basically, it's like in Candyland. You started it, let's say your game piece is over here, and they want to know what H3O plus is. You just do the subtract from 14, get you this. 10 to the negative pH gets you H3O plus. So there's a lot of problems that are going to be on there that are just pH land. The second thing they're going to ask you is to find the pH, and you'll notice in the problem you're given Ka or Kb. If that's the case, I'll show you a little ice table, but ultimately the ice tables always end with x squared on the top, molarity on the bottom. You get to throw out the x is equal to Ka. So what you'll see in the problem is they'll give you M and Ka, and you find x. Once you find x, depending on what it is they will, if it's Ka, it's the same thing as H3O plus. To find pH, you take the negative log. If it's Kb and you find x, it's the same thing because B is a base, is OH. So you take the negative log, subtract it from 14, and then you get the pH. Because ultimately, if something has a pH, we're always trying to get over here in pH land, because 1 to just below 7 is an acid, and then above 7, 7 is neutral, but a 7 to 14 is basically a base. So you want to think of it that way. The more complicated one is where they ask you to find Ka or Kb. Notice how normally we throw out the x and the one above. All you have to remember in this one is keep the x, yo. So if they ask you, hey, what's the Ka or what's the Kb, all you have to remember is all you do is keep the x. So instead of throwing it on the bottom, so they're going to provide you in the problem with M and x, Bing and Bing, keep it there. You get Ka or you get Kb. The only other type of calculation problem on there is anytime it says neutralization, it's a titration equation. Every titration can be done like this, even your labs. It's the molarity of the acid, volume of the acid. You can leave it in milliliters, and you'll see that. The number of H pluses from the formula of the acid, number of OHs, molarity of the base, volume of the base. They'll give you all of them except one thing, kind of like in your lab, and I'll show you. All you're doing is solving for the missing variable. That's all you're going to do. So first problem, problem number 1. Find the value of the unknown in the table. They're asking you for the molarity of the acid, so they're asking me for Ma. First thing I notice is there's 1H, so I put in a 1 there. The volume of the acid, I subtract final minus initial, so 16.12 minus 2.51. I'm going to get 13.61 milliliters goes right there. Ma is that. Equals the molarity of my base is given to me. This is kind of like your lab if you think about it. 0.100 molarity. And then the volume is subtracting this from this is going to be 18.65 milliliters. I can drop milliliters in there, so I just drop 18.65. Bam. And then how many OHs? That's where you have to be aware on the test. How many H's or OHs? I put a 2 in there, and then you algebraically solve. You're solving for the molarity of the acid, so all you're basically doing is taking 0.100 times 18.65 times 2 and dividing by 13.61 milliliters, and you get your answer. Should have been given to you in class. Next one, number 2, same exact idea. It talks about an unknown table. It's a lab. So if you look, they're asking you to find the molarity of the acid. Again, if I first look, it's how many H's. I have 2 H's. I have 3 OHs, so I put a 3 there. Then I go to work, and I look at my volumes. 17.13 minus 2.78 is going to give me 14.35 milliliters right there. Equals molarity of the base is 0.121 M. Volume of the base is going to be those two subtracted, which is going to be 19.61 milliliters. And it becomes a little bit of an algebra problem. We'll call this X or whatever you want to call it. So 2 times the 14, 2 times the 14.35 milliliters goes there. When you look at sig figs, just look at the table. As far as sig figs go, you got 3 sig figs there, so your answer should be in 3 sig figs because by subtraction it's the least number of decimal places. So ultimately your smallest number is going to be 3 sig figs. The number of H's and the number of OH's don't contribute to sig figs. Yet again, same thing. Anytime it says neutralization, you can use this. So it says to use stoichiometry, but really, if you just focus on the number of H's and the number of OH's and not ignore the coefficient, it's a cleaner problem solving. Same thing I teach in AP. So if you do 3 here, there's 1 OH there. I grab it, it says 35 milliliters of phosphoric acid, so I drop 35 ml right there. And it requires, the molarity is 0.7500 m. The volume of the base is 72.85 milliliters. I'm good to go. X. So then all I have to do is basically, when I set it up, 35.00 milliliters on the bottom times 3 will get you your value, get you your answer. It's just a quick calculation from that point. Next thing is there are pH line questions. If they ask you what's the pH of something, like if you look here, you're dissolving 0.216 NaOH. The cool thing to focus on, or the easy thing to focus on, is OH. Because ultimately it's asking you pH, so they're going to start you here, but you need molarity. So remember, molarity from before is moles over liters. So I divide that by 40. That's the molar mass of NaOH, which that's going to come out to be, when I divide that by 40 right there, change into moles, I'm going to get 0.0054 moles of OH, or NaOH, but really it's just OH is what we care about. You have that. Then I divide it by liters, which is going to be 0.165 liters. So when I talk about pH line, just think of it like this. I just have to take whatever value I start with. So when I calculate that out, I get that divided by that is going to be equal to 0.0327 molarity. So I have 0.0327 molarity, which basically means my OH is 0.327 m. So then all I have to do is take the negative log of it. So I take the negative log of this. When I take the negative log of that, what is that? So I'm going to go 0.0327. Take the negative log of it. I'm going to get, remember when I go to pH or POH, the number of sig figs becomes decimal places. So I'm going to get basically 1.485. Then to hop over here, I just subtract from 14. So I go 14 minus 1.485. Cacao. I get 12.515 would be your pH in that case. Remember, in pH line, you should write this on the test before you even start. Write it on there wherever you start. It's like in Candyland, I start here, I hop here using negative log. I subtract from 14 to move over there, and I get my pH. Same thing with this. They ask you what's the hydroxide ion concentration, which has a pH of 12.5. If I start at 12.15, if I start with 12.15 right here, my first move, I would move over to POH, so I would just go 14 minus 12.15. I'm going to get 1.85. Then to go from POH to OH, it's just 10, so I would go 10 to the negative 1.85. So when I punch it in there, I go 10, 1.85 negative. I'm going to get point, and then sig fig wise, when I go back up to the top, only the decimal places count. So I have 2 decimal places here, 2 sig figs, so my answer would be 0.014 molarity. That would be my answer of hydroxide ion concentration. But pay attention where you start. It's like a board game. You always start at the starting space. On this test, they're going to have you start one of these 4 places and you have to manipulate it. Here you go again, another pH line problem. What is a hydronium ion concentration where the hydroxide ion concentration is this? So I have 1.56 times 10 to the negative 8th right there. They're giving me that. They want me to go there. The relationship between this and this is equal to 1.0 times 10 to the negative 14th. So all I do is take 1.56 times 10 to the negative 8th, divide 1.0 times 10 to the negative 14th, and I'll hop right over and get that. So when I do that, I'm going to go 1.0 e negative 14 divided by 1.56 e 8 negative. I get 6.41 times 10 to the negative 7th. That's my H3O plus, or hydronium ion concentration, same thing. If I want to know the pH, if I hop from here to here, which I just did, mathematically I take the negative log, so I hit log, sign change, and my pH now, since I have 3 sig figs here, my pH value has to have 3 decimal places. So it's going to be 6.193 would be my pH in that case. Okay? Again, pH line. Next one. Find the pH of a 4.25 solution of acetic acid, and they give you a Ka. This is the example I was telling you about right here. When we talk here, this is what they're asking you to do. Right here, find pH, and you see a Ka or a Kb given in the problem. Ultimately, it's always going to be equal to this. If they give you a Ka or Kb, it's going to be x squared divided by molarity is equal to Ka. So if I come back over here, and I look right here, ultimately, let me do a quick little ice table. You're going to get the same thing every time. You go HA plus water. That's the formula for a generic form of a weak acid. Acids give H's, so you're ultimately going to get H3O plus A minus. And then I'm going to do an ice table. So if I drop the 0.425 right there, that's my starting value. This is 0 and 0. Always minus x, always plus x, x, 0.425 minus x, and we're allowed to delete the x. So ultimately, every ice table is going to lead you to x squared over m is equal to Ka anyway. So then I'm going to just go 0.425 x squared is equal to 1.8 times 10 to the negative fifth. So then what I do is I basically to solve this, I'm going to multiply the 4.5, cross multiply. So I'm going to do 1.8 times 10 to the negative 1.8 times 10 to the negative fifth. I'll multiply those out. When you multiply that out, so basically x squared is equal to, what is that, 7.65 times 10 to the negative sixth. To get get down to x, I take the square root of it, and then ultimately my x is equal to 2.77 times 10 to the negative third. Remember, it's Ka, which means when I start this problem, the second step is I go to pH land. I just found whenever I have a Ka here, x is equal to H3O plus or H plus. It's the same thing. So I'm right here in pH land. If you think about it, I'm here, 2.77 times 10 to the negative third. So all I have to do is take the negative log of it, bam, and I get pH. So I'm going to go 2.77, E negative 3 log sign change. 3 sig figs going in means 3 decimal places, so I'm going to end up with 2.558. That is an acid. I knew that already because of the Ka, but the pH value is 2.558 is your final pH value. That's all you're doing. If you're given Ka or Kb, look right here, I'm giving Kb. I'm going to skip the ice table. I'm just going to get right down to business. 0.617 over x squared is equal to 1.77 times 10 to the negative fifth. So the first thing I have to do is I'm going to take 0.617 times 1.77 e negative fifth. I'm going to get, when I get that, I'm going to get 1.09 times 10 to the negative fifth is equal to x squared. Then I take, to get x, I just take the square root of that sucker. So I'm going to square root that, and I'm going to get 3.30 times 10 to the negative third. At that point, since this is Kb, that's a Kb, that means x is equal to OH minus. They're asking me for pH, so how do I find pH? Negative log, I get POH. Subtract it from 14, bam, I get pH. So my first step is negative log. I'm going to get, and remember, 3 sig figs going in means 3 decimal places for POH. I'm going to do 2.481. Then I'm going to take 14.00 minus 2.481, and I'm going to end up with 11.519, which basically it's a base, so you know basically it's a base. Did I just say that? You know that it's going to be above 7. But the idea is when they give you Kb, all you have to do is it's ultimately every ice table is going to be x squared over molarity. In this case is Kb. X is equal to OH minus. So in pH line, you're starting there. Negative log POH. Subtract it from 14, you get pH. Bam. Next one. Identify the dissociation reactions as Ka or Kb. Explain how you know. There's an H there. It's an acid. But see the H3O plus is a product? I know it's a Ka. The fact that it produces H3O plus means it's going to be an acid equilibrium problem. If you look right here, I see OH minus on the right hand side as a product. I know it's going to be a KB. Easy, easy to spot. Next one. This table, when you go to this table, it's just pH land is all it is. You're basically going to be given one value. So like here, see the H means it's an acid, and it's 0.0001. So I'm going to go 0.0001. I drop it down in pH land right there. I'm going to take the negative log. So the negative log would give me 1.0 times 10. Or wait, actually, no, that would be 4, actually. 1.0. Yeah, this would be 4, actually. pH, that's going to be 4, right? Then I subtract it from 14. My pOH is going to be 10. If I go 10 to the negative 10th, I'm going to end up with 1.0 times 10 to the negative 10th. And I'm able to scoot around. That's another example of pH land. If you look right here, the trick here you have to pay attention to is the OH. There's double the amount of OH. So before I start my value at OH there, I have to double it. So I take 3.6 times 10 to the negative third times 2. I double it, so I'm going to start with 0.0072 is what I start with. And then it's the same thing. If I take the negative log of that, I am going to get 2.14 is my pOH. If I take 14 minus 2.14, I get 11.86. Boom, bam, boom. And then to hop back this way, I would just go 10 to the negative 11.86. So what's that going to be? 10, 11.86 negative. I'm going to get 1.4 times 10 to the negative 12. Why? Because I have 2 decimal places here, turns into sig figs there. The bottom's driven by decimal places. If you look at this last problem, I'm not going to do this. See the double H's right there? Boom shakalaka. When I go to start this, I'm just going to take this value before I drop it in here since it's H. I'm going to double it and do the exact same thing. That's why knowing this, writing this on your test paper is crucial. Next thing, they asked me to calculate KB. That means keep the X. That's all that's going to mean if you think about it like that. So remember, when you go to find KB, it's going to be X squared over molarity minus X in this case is going to be equal to KB, which means they have to give me 2 numbers. They give me molarity right there, so I'm going to go 0.0065 over, and then minus. Notice how they give me a pH of 10.64. If I go back to pH and think about it like this, for this to work, X, if it's Ka, it has to be either H3O plus, or if it's Kb, it has to be OH minus. Since they're asking me for a Kb, I need OH minus. That, I can just use pH land to basically convert that. So if I had, I'm going to go back to this one right here. If I'm 10.64 and I need to get here, all I do is I'm going to take, okay, 14 minus 10.64 is 3.36. Then I'm going to go 10 to the negative 3.36. And ultimately, I'm going to get 4, because the 2 decimal places, right? I'm going to get 4.4 times 10 to the negative 4th. That's my OH concentration. So really, to do this problem, all I'm going to do is go 4.4 times 10 to the negative 4th goes there. I put X there, and I'm going to put 4.4 times 10 to the negative 4th up here, and I'm going to square it. And then after that, you just pop it into your calculator. The key is, if they ask you for Ka or Kb, all you have to do is keep the X. The second question asks you, what's the concentration of the undissociated? That's undissociated is just always M times X, M minus X. That's the value you get when you subtract the 2 numbers on the bottom. So 0.00650 minus 4.4 times 10 to the negative 4th. Next one. If you look right here, number 12, let's see what they're doing on this one. They're asking me to calculate OH minus and pH. Notice how they give me Kb. So ultimately, I know I'm going to have X squared over molarity is equal to Kb. If I wanted to do the generic version, or let's say I'll just do this, C5H5, N is a base, plus water. Base is, according to Bronsted-Lowry, take H's. So I move an H over, always going to get OH minus. I knew that from the Kb. which ultimately is C5H5NH plus. So if I want to do an ice table, let's say, I would go 0.140. This is going to be 0, 0, X, X, drop them down, X, X. Kind of anticlimactic. This is going to be 0.140 minus X. So ultimately, I'm going to get X squared over 0.14, dropping the X, is equal to 1.78 times 10 to the negative 9th. So then all I do is I'm going to multiply that times that. So whatever that comes out to be is going to be 0.140 times 1.78 E9 negative. Take the square root of it. So then I get that. X ultimately, when I have to take the square root of that, I ultimately get 1.58 times 10 to the negative 5th. Since this is KB, X is always going to be OH. So I found my OH. Think about pH land. On all these problems, a lot of times when they ask you for pH, if I know this is 1.58 times 10 to the negative 5th, take the negative log of that, so I got negative log, boom. I'm going to end up with 4.802. Then I'm going to subtract that from 14. Bam, and I get my pH. Last couple ones. Let's see here. I'm running out of time here. Bronson-Lowry acids and bases. So they talk about Bronson-Lowry acid loses an H. So see how there's two H's on this side? It only has one there. That makes that an acid. That has one H. On that side it has two. That makes that a Bronson-Lowry base. And that makes that a conjugate acid and a conjugate base. If they ask you about conjugate acid-base pairs, remember the difference between a conjugate acid-base pair is a single H. So like if I have H2CO3 and I want that's going to be my conjugate acid, my conjugate base, just take an H off would be HCO3 minus. Here I have four H's, there's three, it goes down, so that's an acid. Here I have 0, now I have 1, that's a base, and they're just the opposites. So this is conjugate acid, conjugate base. Here I have 3 H's, here I have 2, so that makes that an acid, 2 there, 3 there, base, conjugate acid on the other side, conjugate base. 3 H's there, 4 H's there, that makes that a base, 2 H's there, 1 H there, that makes that an acid, then a conjugate base, conjugate acid. Titration curves, when you go to do titration curves, whatever you start with the starting substance, look at the pH. If you notice here's 7, it starts above. If it's a weak base, the pH has to be a weak base, the pH has to be below 12. If it's above 12 when you start, it has to be a strong base. That's an easy way to tell from there. And then the equivalence point, when you start with this is a weak base, will always be below 7. So the equivalence point has to be below 7 on a weak base when it's being titrated. When we titrate, we always titrate. You see the HNO3 there, we always titrate with strong acids anyway. So we're titrating with a strong acid, and notice how the pH goes below 2. That's an easy way to tell it's a strong acid. So if you start with a strong acid pH curve, you know that, like, for example, here, let me draw it real quick. Let's see, here's the pH of 2. If you start below 2 and you get something that looks like this, the equivalence is at 7. That's a strong acid, strong base titration. If you had a weak acid, if I want to change the curve to a weak acid, strong base titration, weak acids, the pH has to be above 2 when you start, so it's going to start with a little curl like this. Because it starts and it's kind of shifted upward, ultimately, what does that mean? It means the equivalence point, because of that shift, ultimately has to be above 7. So on a weak acid titration, you see the equivalence point. Equivalence point is above 7. Okay, and there you go. Hope that helps you review.